Hi everyone. In this lecture we are going to talk about link layer switches. So what's a link layer switch? It's a link layer device and it takes an active role in forwarding and storing Ethernet frames. What a switch does is that it examines an incoming frame's MAC address and then selectively forwards this frame to one or more outgoing links. The switch is transparent. That is, the hosts within the network are unaware of the presence of switches in the network. A switch is also plug and play and self-learning. That is, switches do not need to be configured. You can just buy a switch from a vendor and just plug it into your network. This helps network administrators greatly because they don't have to configure the switch. So let's have a deeper understanding of how a switch works. We just said that switches are plug and play and they are not, and hosts in the network are not aware of the presence of the switches. So the way a switch is introduced in the network is shown in this figure. That is, here is a switch and all these different hosts are connected to this switch. We have different interfaces. So this is a kind of a star topology. What the switch can do is, because of its presence, it can allow multiple transmissions to take place simultaneously. That is, A and A prime can send the frames to each other at the same time as B and B prime without any collisions. So because of the presence of a switch, multiple simultaneous transmissions can take place at the same time without collisions. But the biggest question is, how does the switch know that A prime is reachable via interface 4 and B prime is reachable via interface 5? So this is a question. We know that first A is going to send out its data frame along interface 1. A believes that A prime can be reached along interface 1. But in the middle, the switch is going to intercept that packet and then it's going to forward, frame, and it's going to forward this frame along interface 4 through which it can reach A prime. The question is, how does the switch know that A prime is reachable by 4? The answer is the switch maintains something like a switch table. It looks very similar to a routing table. What it has is that the MAC address of the host and the interface through which the host can be reached and a timestamp. So what it keeps is it keeps a list. It keeps track of through which interface a particular host can be reached. The next is, once this it's clear that a switching table can be created, but then how are these entries created in the table? Does the switch use something like a routing protocol? Actually, the protocol that the switch uses is different from a routing protocol. Switches are self-learning. A switch learns which hosts can be reached through which interfaces when these hosts transmit frames, and each time a switch receives a frame, it records the sender and the interface through which that sender can be reached. Let's look at this for an example. Let's say that A and A prime are communicating and A wants to send this a frame to A prime. So what A does, it first sends this frame along its interface, that is interface 1, and when the switch receives this frame, it records the MAC address of A and its interface and the interface in this table. It also puts TTL, which just says how long this entry is going to be valid. So this approach of the switch can be coded up using an algorithm, and you can can take a look at this, but I'll just show you via an example. We just we just noted that when A wants to communicate with A prime, it sends the packet, it sends the frame along interface 1, and the switch intercepts this frame. The switch then notes that the MAC address of A is A, and the interface through which A can be reached is 1. The next question is, how does the switch reach A prime? It does not know currently through which interface A prime is connected. So what it does, it sends a broadcast message. Basically, it floods this packet along, or I should say frame, along each of its outgoing interface. It is clear that A prime, because it's in this network, it should be connected to at least one of these outgoing interfaces. And as a result, A prime can receive this frame. Next, let's assume that A prime now wants to contact A. What it does is it sends the packet, or sorry, it sends the frame along interface 4, and when the switch receives this frame, what it does is it extracts A prime and puts basically in the MAC address A prime the interface 4 and another TTL. To forward this frame to A, it does not need to broadcast or flood this frame. It knows that A is reachable through through interface 1, because this information is available in the switch table. So what the switch does is that instead of broadcasting or flooding this frame, it just looks at this table and sends the frame along interface 1. In this way, this is how switches populate their switching tables and are self-learning. It's also clear, it's also very simple that switches can be connected together. Switches can be connected together in this form, and they can form a hierarchy. It is actually true that institutions connect switches in this network. So there's a question for you: is if this host here wants to send some some frame to this host G here, the question is, how does switch S1 know it has to forward the datagram to switch S4 and then through switch S3? So the answer to this question is that switches are self-learning, and so you can, this similar to what we discussed in the previous slide, you could populate the switching tables at S1, S2, S3, and S4 such that the frame from A passes through S1, S4, and S3 and finally reaches G. So this slide here shows how an institution's network is connected via switches. So there are multiple switches within the network which are then connected to another switch, and this switch is then connected to the router. So this is the gateway router of the network, which is then connected to the external internet. So I would like to conclude this video by just pointing out the differences between switches and routers. Both switches and routers store and forward, but the most important difference is that routers are network layer devices, whereas switches are link layer devices. As routers are network layer devices, they examine network layer headers. In contrast, switches being link layer devices examine link layer headers. Next, both switches and routers have forwarding tables. However, routers compute their tables using routing algorithms and IP addresses. Switches, on the other hand, use MAC addresses and they populate the forwarding table via self-learning. With this, I'll conclude this lecture. Thank you for watching.